Good afternoon students. So in our previous class we have done till exercise 13.1 question 2. Okay, now we are going to start from question number 3. So the question number 3 is actually based on question number 2, which is in question 2 above, if one part of a red pigment requires 75 ml of base, how much red pigment should we mix with 1800 ml of base? So question is like this. So we have the red pigment and then we have the base. So the question is very simple. In the question it is given one part of red pigment requires. So one part, let us say the one part is actually equal to 75 ml. Sorry, if one part of red pigment requires 75 ml of base, then how much red pigment should be mixed with 1800 of with 1800 ml, how much should we mix? That is the question. So it's very simple. We have to apply that proportion method, which is 1575 is equal to x by 1800. From here, x is equal to, this should go here, and 75 will remain in the division. Okay, then we will get, we have to divide 1800 with 75. Let's start with 5. If you divide with 5, we will get 15. Sorry, 25. 15 5 7 is 15. Here we will get 5 3 15. 3 0 5 6 60 by 15. So then we will divide in 5 again. 5 3 5 7 35 1 5 2 10. So 3 divided 3 to 6 3 4 12. So the answer that is I am getting is 24. So 24 is the answer. So 24 parts, for 24 parts of red pigment we require 1800 ml of base. Okay, students, now let's do the fourth one. In the fourth one, a machine in a soft drink factory fills 840 bottles in a 6 hour. So in 6 hours it is able to, that machine is able to fill for 840 bottles. How many bottles will it fill in 5 hours? Okay, so this is bottles filled and this is time taken. Okay, so how many bottles are filled? 840 bottles are filled in 6 hours. 840 bottles are filled in 6 hours. Then the question is, how many bottles can we fill in 5 hours? So see, in 6 hours 840, we have to apply the direct proportion. So direct proportion method is 840 by 6 is equal to x by 5. We want to find the value of x, so x is equal to x is equal to 840 into 5 divided with 6. If we divide 840 with 6, we will get 616 64 24. 64 24. 140 into 5, which is equal to 140 616 24 64 24 0.7. So I think 700 bottles can be filled. 700 bottles will be filled in 5 hours. Okay students, now look at the fifth one. In the fifth one, a photograph of a bacteria enlarged 50,000 times attains a length of 5 cm as shown in the diagram. Okay. Now, what is the actual length of the bacteria if the photograph is enlarged 20,000 times only, and what would be its enlarged length? Okay. So, a photograph, we are talking about a photograph of a bacteria which is enlarged 50,000 times, attains a length of, when it is enlarged 50,000 times, it attains a length of 5 cm. So here the actual length, let us assume the actual length dx. So here there is a formula, very simple formula, which is the enlarged into actual length gives you the, which is enlarged times into actual length is equal to attained length. So enlarged times, how many times it is enlarged? 50,000 times. 50,000 times into actual length, which is x, is equal to attained length. How much it attained? 5 cm. So here x is equal to 5 divided by 50,000. This will get cancelled. We will get 1 by. So this can be written as 1 by 10 power 1, 2, 3, 4. 10 power 4. 1 by 10 power 4 can also be written as 1 into 10 power minus 4. I told you in exponents chapter, whenever we have a power, whenever we have a number in power minus the power, we can take exponent. So reverse way also is possible. So when it is in denominator, if you move it to the numerator, the power will become minus. Okay, so the actual length is 1 into 10 power minus 4 centimeter. Now the question is, actual length we have found the actual. If the photograph is enlarged 20,000 times only, what would be its enlarged length? So see, it is enlarged 5,000 times, 50,000 times. When it is enlarged 50,000 times, it is getting only 5 cm big. Now when it is enlarged 20,000 times, how big it will become? That is the question. So see here, here we have the diagram quotient formula, which is 50,000 divided by 5 is equal to 20,000 divided by 5. So we want to find the value of 5. So y we bring here, we will keep 20,000 here. We will move this 50,000 to denominator. This will come here and this will come here. Multiply with this 5 will go here. Next to 20,000. So we get y is equal to 20,000 into 5. So we are getting y is equal to 20,000 into 5. See here, 1, 2, 3, 4, 0. 1, 2, 3, 4. This zeros will get cancelled. This 5 and this 5 will get cancelled. So final answer is actually 2 centimeter. So when we enlarge the bacteria 20,000 times, we will get a picture which is only 2 centimeter. Okay. Now see the sixth one. In a model of ship, the mast is 9 centimeter high, while the mast of the actual ship is 12 meter high. If the length of the ship is 28 meter, how long is the model ship? So in a model of a ship, the mast is 9 centimeter high, while the mast of the actual ship is 12 centimeter. So the mast is 9 centimeter, while the mast of the actual ship is 12 centimeter. Now, if the length of the ship is 28 meters, so the length of the ship means this is 28. Okay. So this is actual ship. Okay. This is actual ship. This is mast of the ship. So mast of the ship is 9 centimeter, whereas actual ship is 12 centimeter. Now the question is, if the actual ship's length is 28 meter, how long is the model ship? So we have to apply the type of question which is 9 by 12 is equal to x by 28. So we will get here x is equal to 9 into 28 divided with 12. So x will give here, this will be moved here, and this will remain the denominator. So here see 3, 3 the, 3, 4 the, 4, 7 the. So we are getting 3 into 7, 21. So for 9 centimeter we will get 12 centimeter. For 21 centimeter of model ship we will get 28 centimeter of actual ship. Okay. Now let's move on to the seventh one. So suppose 2 kilo of 7th one, suppose 2 kilo of sugar contains 9 into 10 power 6 crystals. How many sugar crystals are there in 5 kilo of sugar? Okay, see. So we have so this is quantity and this is number of crystals. Okay. So the quantity is given here is 2 kilo of sugar. 2 kilo of sugar contains how many crystals? This is number of crystals. Okay. Number of crystals in 2 kilo of sugar is 9 into 10 raised to 6. How many sugar crystals are there in 5 kilo of sugar? So we have to find in 5 kilo of sugar how many crystals are there, and in 1.2 kilo of sugar how many crystals are there. by 9 into 10 raised to 6 is equal to 5 divided with y1. So from here we will get y1 as y1 will go here. Let's keep 5 there. We'll go bring 9 to the power 6 to the numerator. Divided with this 2 will come to the denominator. So final answer that we will get is 9545 into 10 raised to 6 divided with 2. So if we divide 45 with 2 we will get 22.5. So we will get 22.5 into 10 raised to 6 crystals. That can be written as 2.25. So I am moving this decimal from here to left. So I told you already, whenever we move decimal towards left, the power will be positive and it will increase. Okay. So this will become 10 raised to how many places it has moved? 1 place. So already this is 1 place it will move means 7. So 2.25 into 10 power 7 crystals are there. Okay. Now in 1.2 kilo of sugar, so here we will get 1.2. So y1 is equal to 1.2 into 9 into 10 power 6 divided by 2. So here we will get 0.6. If you divide 1.2 to 2, we will get 0.6 into 9 into 10 power 6. So see here, 0.6 can be written as 6 by 10. 0.6 can be written as 6 by 10. So I am writing it as 6 by 10 into 9 into 10 power 6. So this 1 0 here and there 1 0 will get cancelled. So if 1 0 will cancel, it will become 5. So we will get 9 into 5, 9 into 6, 54 into 10 power 5 crystals. 54 into 10 power 5 crystals. Okay. Now look at the 8th one. So the 8th one, let me read out. Rashmi has a road map with a scale of 1 centimeter representing 18 kilometers. So 1 centimeter is equal to 18 centimeter. 1 centimeter on the map is actually in reality it is equal to 18 kilometer. So she drives on a road for 72 kilometer. What would be her distance covered in map? So here in map we have a distance and then in reality we have a distance. So in the map the distance covered is 1 centimeter. This 1 centimeter is equal to 18 kilometers. Okay, now the question is, she drives on a road for 72 kilometers. So what is the distance on that map? If in reality she travels 72 kilometers, then in map how much distance she will cover? So see, applying the direct proportion, we will get 1 by 80 is equal to x by 72. From here we will get x, value of x. Value of x is equal to how much? Keep x here, bring 72 to here. We will get 72 into 1, which is 72, divided by 18 is equal to how much? 18 for 72. So the answer is 4 cm. So in math she will be covering 4 cm, whereas in reality she will be covering 72 kilometers. Okay. Now look at the 10th one. So 10th one is a loaded truck travels 14 km 25 minutes in 25 minutes. So 14 kilometers are traveled. So the distance and this is time taken. Okay, so the distance traveled is 14 kilometers. In how much time? In 25 minutes. Next is if the speed remains the same, how far can it travel in 5 hours? So see here, one data is given in minutes, another data is given in hours. So what we will do, we will convert that into minutes. 5 hours is how much minutes? 5 into 60, which is 300 minutes. So this is 300 minutes. So in 300 minutes the distance traveled is how much? That is the question. So we will apply the direct proportion here. So we will get 14 divided with 25 is equal to x divided with 300. We want to find the value of x, so x is equal to, this has to move from here to here, 14 into 300 . 14 into 300 divided by 25. So here we will, if you divide 300 with 25, we will get 25 on the 25, then 50 25 to 50. So we will get x is equal to 14 into 12, which is equal to 168. 168 kilometer. 168 kilometer can be traveled in 300 minutes. Okay, students. So students, with this exercise 13.1 is over. Now we will study inverse proportion. So students, inverse proportion. So what happens in the inverse proportion is, see, in page number 209 there is an example given, speed in kilometers and time taken. See, speed in kilometers, speed divided with time taken. So speed is how much? Speed, and there are many cases given, right? Okay, so here many cases are given, like walking, like running, like cycling. So see, the data that is given here is 3, 30, 6, 15, 10. So as you can see, at the speed of 3 km per hour, the time taken to cover a certain distance is 30 minutes. Okay, this is hours. This is in kilometer per hour, and this is in minutes. Okay, so with 3 km per hour speed, it takes 30 minutes. If you increase the speed to 6, the time taken will be reduced. If you further increase the speed, the time taken will reduce further. So this is called inverse proportion, where a certain quantity increases and a certain quantity automatically reduces. Okay. Now in the inverse proportion, there is a formula which is, in the direct proportion we have studied this formula, x1 by y1 is equal to x2 by y2. But in inverse proportion, this is not a formula. Here the formula is x1 divided with x2 is equal to y1 y2 divided with y1. So here x1 is divided with x2 followed by equal to y2 divided by y1. So in this case it will be like this. x1, this is x1, this is x2. So 3 by 30 is equal to y2 is how much? 15 by 6. So this is how, although this is not equal here in this case, but this is how it is actually applied. Okay. Now let's start with example question. Example 7. 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used? See, one thing is very clear. The more number of pipes you use, the faster the tank will be filled. Okay, we are talking about filling a tank. The more number of pipes you will use, the less amount of time it will take to fill the tank. Whereas if you use less number of pipes, it is going to take a lot more time to fill the tank. Okay, so here how long will it take? How long will it take if only 5 pipes? Okay, so in this case, see. So here in the book you can see number of pipes. Number of pipes divided with time. Okay, so the number of pipes is how much? 6 pipes. And for 6 pipes it takes 1 hour 20 minutes. See, 1 hour is 60 minutes. 60 plus 20, 80 minutes. So total how much it will take? How much it will be? 80 minutes. So next question is, how long will it take if only 5 pipes of the same type are used? So instead of 6, if we use 5, obviously 6 pipes takes 80 minutes, then 5 pipes are going to take more than 80 minutes. Yes or no? Yes. So now what we are going to do, we will apply here inverse proportion. So in inverse proportion, this is x1, this is y1, x2, y1. So here we apply, we will get x1, we have to apply x1 divided with x2 equal to y2 divided with y1. Or we can make another form out of this. We can multiply this to, we can x1 y1 equal to x2 y2. I think this is much easier formula. x1 y1 is equal to x2 y2 is much easier formula, so we will apply that. So if we apply x1, y1 is equal to x2 y2. We will get x1 is how much? 6. y1 is how much? 80. x2 is how much? 5. y2 is how much? We do not know. Then y2, we keep y2 here. We will remove 5 from here and it will come here in the denominator. So 60 into 80 divided with 5. So with 50, if 5 we add and divide 80, we get 69. So 60 into 6 is 96. We will get 96. So that is our answer. So 96 minutes. Okay, obviously see, 6 pipes it took only 80 minutes because more number of pipe means it will take less amount of time to fill the tank. If you remove one pipe, it is going to obviously take more time, which is 96 minutes. So our answer is right. Okay. Now look at the 6th and 8th example question. So the 8th one, the question is, there are 100 students in a school. Food provisions for them is for 20 days. How long will these provisions last if 25 more students join the group? So here, there are actually 100 students in a hostel and food provisions are for them is for 20 days only. Okay, so whatever they have taken ration, it's only for 20 days. For 100 students, it is only for 20 days. Whereas 25 more students join the group, then what will happen? The provision will reduce. The number of days that provision can be consumed will reduce. Okay, so now number of students. Divide with number of days. Okay, number of students divided with number of days. Example 8. So here, number of students is 100 and the food provision was for 20 days. Now 25 more students joined, which means already 100 was there, plus 25 is 125. So automatically when 125 students will join, the food provision will automatically reduce because more people are there for consuming the food. So automatically this will reduce this. Let's say x1, y1, x2, y2. Okay, now we want to find it. We will apply the inverse proportion. x1, y1 is equal to x2, y2. So x1 is how much? 100. y1 is how much? 20. x2 is how much? 125. y2 is how much? 5. Okay. So from here we will get y2 plus, we have to find the y2, so we will keep y2 there. We will move 125 from here to denominator. So 100 into 20 is already there. 125 will come in the denominator. Okay. So if you divide 125 with 5, you will get 25 into 5 is 125, 25 into 4 is 100. With 25 we divide, okay, with 25, if we divide both, we will get 25 into 4 is 100, 25 into 5 is 125. So I divided 100 and put 125 with 25. Next we are getting 4 into 20 divided with 5. So with 5 we can divide 20, we will get 4. So 4 into 4 is 16. So the answer is 16. So if the number of students became 125, the food provision is going to last for only 16 days. Okay students, now look at the 9th one. If 15 workers can build a wall in 48 hours, okay, so if 15 workers can build a wall in 48 hours, how many workers will it be required to do the same work in 30 hours? See, 15 people can build a wall in 48 hours, and if the same wall has to be built in 30 hours, then it's obviously going to take more number of people. Yes, see, this is workers. And this is days. So 15 workers can complete the work in 48 hours. Okay, time, number of hours. Number of hours, we can put any order, but I am following the book one. Number of hours is equal to number of workers. We can put 15 by 4 also, 4 by 15 also. We can put this on the top, this on the bottom also. No difference is going to make. We will get the same answer. But to avoid confusions, I am following the book one. Okay. So here we will get number of hours is 48. How many people work? 15 people work. Next is how many workers will be required to do the same work in 30 hours? X1, Y1, X2, Y2. So obviously it is going to require more number of people. So here we will apply X1, Y1, X2, Y2, inverse proportion. Okay, so in direct proportion it actually increases, in inverse proportion it will reduce or it will increase. Whenever something is increasing it will reduce, or it is decreasing it will, if it is decreasing the other value will increase, that is inverse proportion. So here X1, Y1, X1 is how much? 48, Y1 is how much? 15, X2 is how much? 30, Y2 is how much? Y2. So from here we will get Y2 as 48 into 15 divided with 30. So 15 to the, with 2 we can divide 48 and we will get 24. So the answer is 24. So we require 24 people to finish the work in 30 hours. Okay students, with this we are over till examples of inverse proportion, and we will see in our next class. Thank you very much.